Module 1, Objective 5, explain the concept of negative feedback and describe how negative feedback mechanisms help maintain physiological homeostasis. Homeostasis is the point at which all body systems work together to maintain a stable internal environment. Often, homeostasis and equilibrium are interchangeable, so when the body is balanced, it's homeostatic. Our systems respond to both external and internal changes to function within a normal range. And the prime example of this would be body temperature. We have a set body temperature of 98.6 degrees Fahrenheit. If we deviate away from that 98.6 degrees, we have physiological mechanisms that kick in order to reestablish our set point temperature. So for instance, if we are at 98.6 degrees and we're put in a warm condition and our body temperature starts to rise, we have mechanisms. We start sweating, we start panting, blood may be shunted superficially to directly underneath our skin so that we can lose that heat, and that in turn is going to cause the body to reestablish its set thermostatic temperature of 98.6 degrees. If we start to become cold, again, we have physiological mechanisms that kick in order to warm us up. So we may start shivering. We may shunt our blood more internally and in turn become pale in color. But all of those mechanisms are there in order to reestablish, to warm us up to our set point. So this set point is very important. And then, of course, having mechanisms on either side of that set point are also important. So how warm can we get? Well, as an adult, we can get to about 105 degrees. At 105 degrees, our proteins denature and we start to die. A child, because of their surface to volume ratio, I always say they're big heads, they can survive up to about 107 degrees Fahrenheit. So we don't have a lot to play in. In terms of the other side, at about 95 degrees, we become mildly hypothermic. So beyond that, if we were to cool down beyond 95 degrees, then again, we could have detrimental pathological response. It could kill us. So we live within a very narrow range of only 10 degrees. And of course, if you consider the environment in which we live, we might have extreme temperatures in the Tennessee Valley of near 100 degrees Fahrenheit. And it may get all the way down to 0 degrees on a very cold day. So environmentally, we live within 100 degrees, while our body has to be maintained within only 10 degrees. So we have lots of mechanisms in order to maintain our set point with respect to temperature. And we do this through negative feedback. Negative feedback negative feedback mechanisms have three main parts. There's a receptor that receives the stimulus. There's a control center that is going to process the signal and send instructions. And then we have the effector, which will carry out those instructions. So our brain is our control center for temperature. It's a part of the brain called the hypothalamus. That's where our set point is, 98.6 degrees. We have receptors that receive stimuli. These are thermoreceptors that are located throughout the body that sort of detect changes in temperature. And if that detection is present, if these receptors detect a change in temperature, they send a signal to the brain. The brain is then going to respond. And if, for example, if the environment cools down and you become cold, if you drop below 98.6 degrees, The effector may be a skeletal muscle that contracts that causes shivering. So these are the three parts of negative feedback mechanisms. Their job is to limit fluctuations of internal conditions to keep them close to that set point. An example that we could have used would have been a thermostat on the wall. We have a thermostat, we set it at a set point. I don't know what comfortable is, 70 degrees. If the room heats up beyond 70 degrees, what happens? Well, the air conditioner, which is the effector, is going to kick on, and it's going to restore the temperature of the room. And when it gets back down to that set temperature, 70 degrees, it kicks off. That is negative feedback. The same can happen in the opposite direction. We have a receptor that is going to pick up the temperature, and let's say it goes below 70 degrees. It drops to 69. That is going to trigger the thermostat to enact an effector. In this case, it's going to be the heat, which is then going to kick on to return our temperature to 70 degrees, at which point the mechanism shuts off again. So that is negative feedback. Our systems all work together in order to maintain this balance, this homeostasis. It is a state of equilibrium where opposing forces are balanced. Physiological systems work to restore balance. In fact, physiology, what our systems do is they're constantly restoring balance. Failure of the body to restore balance results in pathology and or death. A good example of this, and we'll move beyond temperature, would be water. If you get thirsty, we have mechanisms that detect when we become dehydrated, and part of the response of that is to become thirsty. We then drink water. If we were to drink too much water, we have mechanisms to get rid of excess water. So we may urinate more, we may sweat more. So we have mechanisms in order to maintain balance. And we've talked about temperature, we've talked about water, but really everything is balanced. It may be sodium in our system, or potassium in our system, calcium in our system. In fact, for the next year, all we're going to do is cover physiology, which is basically how the body maintains balance of everything. So we're going to systematically work through that. So negative feedback comes up time and time again.